Now, if you are not in a comfortable place, move to a comfortable place and sit back because we're going on an endless journey together. And at the end of the video, there are two possibilities. Either you will completely forget yourself, who you are, where you are, or on the contrary, you will find your true self. Are you ready for an existential journey? The universe, minus 93 billion light-years in diameter, according to the latest estimates. If you ask how a universe born 13 billion years ago can be 93 billion light-years in diameter, it has to do with the rate at which the universe is expanding. As we know, the universe has been expanding at an accelerating rate for a very long time. So the speed of light is not the limit for the universe. But we can talk about that separately. But for now, when we say 93 billion light-years, we say, that's pretty big. But these kinds of numbers, these distances, are really very difficult to perceive, to understand. It needs to be concretized, and that's what we're going to do today. How big the universe is, and why is that? We'll talk about that at the end of the video. If you're ready, let's begin. First, let's start from our point zero. Let's start with the pale blue dot we are on, our Earth. We don't actually live on a very small planet when you think about it. We said to make it concrete. For example, if you jump in a car, if you traveled around the world at 100 kilometers per hour without stopping, you would have to travel more than 17 days. If you say that would be too tiring, if you jumped on a passenger plane, you would still have to travel more than 2 days. So we don't live on a small planet at all. We have been traveling on this rocky planet for hundreds of thousands of years, settling, living, dying, and we still haven't finished. Many people's lifespan ends in a very limited area without even seeing other cities, let alone continents. What a big world. Anyway, our minds have no limits, do they? Let's leave the world. To our nearest neighbor, let's go to the moon. When we look at photographs, animations, it looks like it's right next to us, doesn't it? As if we could reach out and touch it on a full moon. But there are 384,400 kilometers between us. Shall we get in the car again? Let's say we made a trip to the moon and drove at 100 kilometers per hour non-stop without a restroom or food break. It would take us more than 6 months to reach the moon. 6 months. Even without a car, we got here. It's the farthest place on the cosmic scale that humanity has reached outside the Earth. 12 people have walked on it so far. It's an amazing feat. But, we're short on time. Let's move on. When we widen our focus a little more, we see other planets. And when we see them in the animations, it seems like they're very close. But of course they're not. It's not possible to show the actual scale. The solar system, a tiny part of the universe that's actually gigantic. For example, let's get back in our car and try to go to the sun. At 100 kilometers per hour, again without stopping for lunch, it would take about 177 years. That's a lot. Let's take an airplane. And that took 19 years. The sun, which we think is right in front of us. What if we give up and go to Neptune? That's even more trouble. By car, it's more than 5,000 years, again without a stop. By plane, 600 years. So, yeah, the solar system is really, really big. That's why just colonizing the solar system is a big dream. But we still push the limits. Even though we couldn't go, the vehicles we built have come a long way. Because these vehicles can travel much faster than a car or an airplane. 30,000, 40,000 kilometers per hour, sometimes even faster. For example, the most distant man-made object in space right now is Voyager 1, which was launched in 1977. It has been traveling at full speed into deep space for more than 43 years. It has long since left the solar system. It left the solar system in August 2012 and is now 22 billion kilometers from Earth. So if you could travel at the speed of light, it would take you about 21 hours to reach Voyager 1. By the way, you can still track Voyager 1's current position and course on NASA's website. So, it's time to slowly get out of the neighborhood. Let's get out of the solar system. But there's a problem. Where is the border? There is no clear answer to that. Some say it's the orbit of Neptune, others say the orbit of Pluto. According to some astronomers, it's a belt of billions of comets known as the Oort cloud. Of course, this uncertainty corresponds to incredible distances. Let's say Neptune is the edge of our solar system. In that case, if we could move at the speed of light, we could reach it in 4 hours. But if we try to draw the boundary from outside, from the Oort cloud, it would take us 1.5 hours to reach it at the speed of light. So there is a significant difference of 4 hours to 1.5 years depending on where you draw the boundary. To remind you again what the speed of light is like, we could reach the moon in 1.3 seconds and the sun in 8 minutes at the speed of light. It feels like if we reach the speed of light, we will solve everything. Even at this speed, it will take a year to get out of the neighborhood. Anyway, we're just getting started. I don't need to tell you that we're just getting started. We haven't even traveled an inch cosmically. When we compare our solar system, which up to this point has seemed to have an enormous size, with our galaxy, the Milky Way, the limits of our minds will begin to be pushed even further. Let's take the nearest star. Proxima Centauri. It's only 4.2 light years away. It's right there. So let's get in the car. Let's try to get there. How long do you think it would take? At 100 kilometers per hour without a stop, it would take about 47 million years. We're in a hurry. Let's take an airplane. 5 million years. We're in even more of a hurry. Let's jump on a space shuttle. If we traveled at the same speed as, say, Voyager 1, it would take 73,000 years. To our neighbor, to the nearest star. I mean, it's not too bad, but if we calculate the human lifespan, even at that speed, we would arrive in 2,500 generations. It's a bit further away. The brightest star in the sky, Sirius, 8 light years away. A little further away, we come to a larger neighborhood of stars. There are 52 star systems in this neighborhood. Some of them are a bit dim. That's why we can't see them. But some of the stars that are much farther away we can see more clearly, like Betelgeuse. It's 645 light years away, but we can see it quite easily, because Betelgeuse is a star 1,000 times more massive than our Sun. But when we look at our own interstellar system, it's 50 light years across. It is a gigantic system that you can reach from one end to the other in 1 million years with Voyager. When we leave this system behind, we reach the radiosphere. When we say the radiosphere, we are talking about the place where human communication and the radio waves emitted by human beings have reached since World War II. And that corresponds to a place like this. I'm talking about that blue dot, so the waves we've been emitting since the invention of radio have just reached the constellation Cetus. If there's a civilization further out in the Milky Way, they haven't even heard us yet. In fact, it's not a small area. There are 3,000 to 5,000 stars in this area we call the radiosphere. It's 160 light years across. But let's get out of here. Let's go 1,000 light years away. Isn't that too far away? But no, it's not even 1% of the Milky Way Galaxy. Can you imagine how big just our galaxy is? A single galaxy with an estimated 400 billion stars. When we say billion, people think, wow, that's a lot. But I want you to think again how big a billion is. For example, if you count one by one, it would take 17 minutes to count to 1,000, 12 days to count to 1,000,000. Do you know how long it would take to count to 1,000,000,000? 32 years. Yes, that's right. 1 billion is that big a number. And when we say 100 to 200 billion stars, I hope I can explain what we're talking about. I wanted to emphasize that because it gets much more complicated. That's why. If there are about 400 billion stars in our galaxy alone, assuming that every star has a planetary system, we're talking about billions of possible planets. And our galaxy is 120,000 light years in diameter and 1,000 light years thick. Let's forget the numbers. Let's put it this way. Let's imagine that our solar system is the size of a nickel. The Milky Way is almost the size of the American continent. Looking for a needle in a haystack is child's play. And remember, our world is also included in this 5 pennies, probably the size of an invisible grain of dust. And on that grain of dust, and on that grain of dust, that's us. Well, anyway, let's keep going. Let's cut the strings. Let's get out of the Milky Way, to the neighbor. Let's go to Andromeda, 2.5 million light years away. Let's go past that. Expanding out to 110 million light years in diameter, we find the Virgo supercluster, which includes us, Andromeda, and the group of galaxies called the local group. There are thousands of galaxies in it, thousands of them. Thousands of galaxies containing hundreds of billions of stars, trillions of planets. No stopping. Let's go further away. We'll come across other superclusters like the Virgo supercluster. Some of them are dark because the Milky Way Galaxy is blocking them. We can't see it. As we go further away, we come across quasars, which are extremely bright galaxies that formed in the young universe. Finally, we come to a map of what we call cosmic background radiation, the radiation left over from the Big Bang. When we look here, we actually reach the limit of what we call the observable universe. It's the limit of the last objects that light can reach us at this moment in time. And it's a giant system with about 2 trillion galaxies. 2 trillion galaxies. I don't think we need to explain the magnitude of the numbers anymore. Does it end here? No, of course not. We now know that the observable universe is 93 billion light years across. Beyond that? We don't know, but as we've discussed before, given the accelerating expansion of the universe, the actual universe could be 250 times larger. Trillions of light years. Now the question is, so what should we do? I mean, what can learning this add to a person? The answer to this is, of course, very personal. But for all the great names in history, philosophers, thinkers, scientists, the answer to this question is actually the answer to everything. Because human beings' efforts to understand the universe and their efforts to understand themselves are actually very parallel. The better we understand the universe, the better we understand ourselves. As Rumi says, don't feel alone. The whole universe is within you. Yes, we are not actually trying to understand the universe. The universe is not a phenomenon that we can think apart from ourselves. The universe is us, and we are the universe in the end. We are biologically connected to each other, chemically connected to our world, and atomically connected to the universe. And this consciousness is a consciousness that can change everything in every sense. This consciousness tells us that we should approach all living beings in the environment with respect and love. It tells us that we may seem very, very small and insignificant, but we are also very special. Knowing that every atom in our body comes from stars that died in their time ultimately tells us the insignificance of fights, wars, and simple troubles. That our time is limited and we should make the most of it. Don't forget to like the video, subscribe to my channel, and leave your thoughts in the comments. And as always, until we meet again, I'm glad you're here. Love.